Hello everyone, welcome back to Learn with W3 Schools. I am Dr. Ishan Bhatti, and for the past 19 years I have been teaching programming to thousands of undergraduate students and learners worldwide, covering a wide range of programming languages and real world applications. And today we are diving into Kotlin programming language using W3 Schools website as a reference. So now you might be wondering why Kotlin in 2025? Well, Kotlin is more than just an alternative to Java. It's an official language for Android app development supported by Google. It's widely used in mobile applications, server-side applications, cloud-based app systems, and even data science and manipulating projects. With its clean syntax, null safety, and seamless Java interoperability, Kotlin is one of the most in-demand skills you have to have today and in years coming ahead. So here's what I need you to do right now. Open up your browser, head over to W3 Schools website, and go to Kotlin tutorial section. Keep it open beside you as we work through these lessons together. I will make your learning experience much more effective. By the end of this session, you will have a strong foundation in Kotlin. So let's not waste another time. Grab your notes, open W3 Schools, and let's dive into Kotlin programming. W3 Schools is a very popular website and it has tons of tutorials, and I'm going to use this as a reference so that you can follow along and learn any programming language with me. So do follow this channel, and I'm posting more videos about W3 Schools and other coding languages as well. Coming back to Kotlin, Kotlin is a modern trending programming language. It's easy to learn, especially if you're already known to Java. It's 100% compatible with Java. That's the major advantage of it. That's why Android Studio uses Java as well as Kotlin. They do prefer Kotlin nowadays, but you can still use Java, and because they're very compatible with each other, it has become much more popular in recent days. And it is officially Google's own defined language. So that means that Google now prefers to use Kotlin for its apps and every other thing. Kotlin is used to develop Android apps, server-side apps, and much more. Okay, so we will be using W3 Schools website, and I will try to go as many content as I can in this entire course. So do follow along and subscribe. I will be posting videos regularly about Kotlin and using it. Okay, let's begin with it. So now the examples in the chapter, or if you have used W3 Schools website, you know what it is. So let's get into the basic syntax of it. Okay, first thing is first, let's get into introduction to Kotlin and understand what exactly is Kotlin a little bit more. Well, Kotlin is a modern programming language. It is trending programming language nowadays, especially since Google is now backing it to a greater extent. So it is It was released in 2016 by JetBrains by default. It has become very popular since it's become compatible with Java, one of the most popular programming languages out there. Again, that's Java, which means that Java code and libraries can be used within the Kotlin program. Now, keep an eye on this statement a lot, because we're going to be exploring this in much more detail in more advanced classes. But what this basically means is that Java code and all its libraries can be used inside the Kotlin programs, making sure that your Java code, which already is written, can be seamlessly used with Kotlin programs. That's the beauty of Kotlin. It is that it has somehow inherited Java's code, and you can very easily use it. And we will explore this into a greater depth later on in advanced courses. Okay, so Kotlin technically is used for mobile application developments. That's the maximum major use we are currently seeing, especially Android apps. Okay, but however, Kotlin is used in web development, server-side applications, data science, and much more. But the more examples you would find are related to mobile application development. Why use Kotlin? Well, Kotlin is fully compatible with Java. Again, as I said, this statement will pop up again and again: Java, Kotlin, Java, Kotlin. To a point that people do argue, why use Java at all, or why use Kotlin at all when everything can be done with Java and it's much more easier and commonly known. But then again, Kotlin has its own advantages. We will talk about this maybe later on. Okay, with few examples so that you can understand what realize the exact difference. Anyway, so Kotlin is fully compatible with Java. Kotlin works on different platforms like Windows, Mac, Linux, Raspberry Pi, etc. Same as Java. Kotlin is concise and safe. Now, this is where the difference starts to pop up between Java and Kotlin. Java is not so much concise. Kotlin is. Okay, and it's safe. Well, Java is an arguably safer. That's a different debate anyway. Let's not get into it right now. Kotlin is easy to learn, specifically if you already know Java. Yeah, so if you know Java, Kotlin becomes much more easy to learn. But if you have never used any programming at all, again, Kotlin can be a wonderful fresh start. Kotlin is free to use, so that's the major advantage nowadays. Well, technically almost all programming languages do end up becoming free. It has a big community and support. Debatable. Still, Java is a huge one with the community and support, but yes, Kotlin is growing, again backed by Google. Anyway, so that's a brief intro of Google. Let's get Kotlin. let's get started with the syntax of Kotlin and how we use Kotlin. Okay. Okay, let's talk more about Kotlin syntax now. Okay, now in terms of syntax, we basically mean how the code is written and how the code is defined and formatted for the compiler to run properly. The first thing is, first, every Kotlin file is saved as .kt for Kotlin. So do make sure whenever you're using whatever editor you're using, either VS Code or JetBrains or Android Studio itself, we basically go inside and use .kt file. Okay, then every Kotlin code starts with the function main. Okay, we use the word fun for function as a small form, define a function name, and bracket start bracket close. So the main basically becomes the major thing. So the fun keyword is used to declare a function. It tells the Kotlin that we are declaring a function. A function typically is a block of code designed to perform a particular task. So function is a block of code that performs a particular task. In this example, it declares a main function and that performs them some task, which is again printing a statement. Okay, the main method is something you will see every Kotlin program has. Okay, so this is something that you will come across every single Kotlin program. This function is used to execute the code. Okay, it tells our compiler, which again is another software that reads the code and checks whether there are any errors or not. Okay, so a compiler will read this code, and it needs this main code to understand that my code is starting from this point. And then when you execute the code, the main function becomes the first line that basically gets executed. So this is where your program starts to execute. This is the starting point of your code. Your code can have 1,000 lines or 1,000,000 lines, but the main function is the first line that technically gets executed in form of an the execution block. Okay, so that's why it's very important. Everything starts from the main function. Okay, so for example, here we have a println. This again is a function inside a function, and this function is executed once this function gets executed. Okay, second, this function prints a statement on the console. Okay, so the println function is used to print output on our console, and in this example it's going to print hello world. Let's test this code out. You will see that W3Schools provides a very nice interface where you can write the code, change the constant text, click on the run, and the output gets printed here. So we can use with the W3Schools own editor for this matter to write the code and perform various different tasks. Okay, so now once we come here, this is the hello world. So what this is doing is the function main is required. It's printing ln and printing output on the console. Do note, if you're coming from Java or any other programming language, there's no semicolon here. Kotlin does not need a semicolon, or you can skip with that. Okay, so good to know, in Kotlin code statements do not have an ending semicolon, which is often required by other programming languages such as Java, C++, C#, and etc. Okay, so do keep in mind Kotlin doesn't need that, Java does. So if you're coming from Java, it's a habit of using a semicolon, but from Kotlin point of view, you don't need that. Okay, so main parameter. Before Kotlin version 1.3, it was required to use a main function with a parenthesis like function, main, arguments, and so on and so forth. The example above had to be written like this. However, this is no longer needed. The program will run without it. Okay, so if you are from an older version, this is again, since we're using W3Schools latest version, it tells us that it's actually no longer needed. You can run it without it. So what it basically is saying is that the older versions of Kotlin had to use function main, same as we just discussed, but it needed an argument list as well. Argument list provides our system or a function a list of data that it might be needed to run the program. Okay, so it's like an additional piece of information that we need to provide while executing the main function. If you're coming from Java, Java does requires arguments. We use system arguments and array, so we use in that form. Here we use args colon array and define a string type, but this no longer is needed. The previous statement is completely valid. You can just simply write main function without any arguments and it will work fine. That's what it says. Kotlin is trying to simplify the code as much as possible, similar to Python, but still not there yet. But yeah, so what it's doing is that, hey, if you're older version Kotlin user, you might be familiar with this syntax, but if you're learning it for the first time, just go with this thing, main function. You might see this code pop up somewhere in old tutorials or anything. Just don't be afraid of it. This basically means that in previous versions, main function needed an argument, now is no longer needed. Capish? Okay, let's talk more about this output print statement. Okay, so now the print statement that we use is basically a function is okay, this print statement. This is also a function, built-in function that the good people of Kotlin have already developed for us, and all we do is we use this function, and then whatever argument we pass inside this function gets printed on the console. That's what it does. Okay, so the println function is used to print output on the console. Every time you need to print something on the console, you just write println and the string here. Okay, so you can add as many println statements functions as you want. Note that once you add, every time it prints a new line. So if you come here, we have a function main. Again, this is something this should be now mandatory back of your head, that every time you write a Kotlin code, you need to have function main, bracket start, bracket close, and block start, block close. Now do mind, in my terminology, I call this brackets, and then when I'm writing a code, these curly brackets indicate a block. So it means that block starts here and block ends here. So usually I would refer it to this, hey, main, bracket start, bracket close, block start, block close. Okay, so once we get to the point of defining our own custom functions in the advanced topics, we will again be using our own custom functions. Same terminology. This block is actually used in multiple other things. So if you go for if, else, bool, while, for loops, all of them also tend to use the block. So that's why we define the block as it goes. Anyway, so you can write as many print statements as you want. You can print ln hello world, I'm learning Kotlin, it is awesome. See this, all these lines without any semicolon, you can write here as many times as you want. Every time you write this line, the key thing to note is that every time you print an output, it will get printed on a new line. So if you come here, you see print ln hello world on a new line, then I'm learning Kotlin again on a new line, it's awesome again on a new line. Why it's on a new line? Because there's a small thing called ln. Actually, the statement is print, but then there's another function called ln. This ln adds new line. So this means print the statement on a new line, but this new line is actually added after the statement is printed. So after your string is printed, the new line is added. So in a word, it says, hey, print the statement and then just add a new line. So print the statement and add a new line. Print a statement and add a new line. Right? That's why the next line actually appears on the new line. Okay, it's not because of this ln, it's actually because of the previous ln. Okay, so once we go back here to our Kotlin code, you would find that you can also print numbers, and then there's a print function here. Sorry, before we go to the numbers, you will find that there is a print function here. So if I come back to this code, this one, okay, so if I don't use this ln here in the middle, if I run the code here, okay, see this, the code appears on one single line. The first line is on a new line because again this is a first line, so it doesn't really matter. But the second line again is on a new line. Yes, I am learning Kotlin. This comes on a new line because this is again println. Notice, but there is no ln here, but still this line is on a new line. Okay, because of the previous ln. So actually this means hello world, add a new line. So this statement automatically starts on a new line. But after this, since there is no ln on this point here, this second line adds up on the same line as well. Hence you get it's awesome on the same line. Make sense? A little bit, right? So just keep in mind that whenever you can write a print method as well as ln method. Every time you write a print method, it basically means just add on a same line. So the next statement will also appear on the same line, even though it has ln. Okay, and then whenever you write ln, it means print the statement, add a new line, break it down. Okay, so anyway, we skipped one thing from here. So print output, everything is fine. Yes, this one here, what it says that within this you can print numbers as well. It's not only string, you can write 3 plus 3, so it's going to do mathematical calculation and then perform the operation here. So if you run the code, you would see that output is 6, okay, because 3 plus 3 is 6. However, if you use string, okay, so if you put this inside the string, now it will basically mean it's going to print the string statement. Make sense? So you can print only a single variable here as well. So if you print 4, this will go and print 4 here, or you can perform calculations here as well. Okay, so the print function, yes, you can use this, but this basically means there's no end line. Everything gets printed on the same line as well. Okay, now let's talk more about comments. Well, comments can be used to explain code. Comments can be there for reference, for some instructions, some debugging purpose, whatever you want. So comments are basically lines of code that is completely ignored by the compiler. Okay, every programming language has it. So comments are a simple way of telling a compiler that please ignore anything after this. So we use a single line comments in Kotlin by double backslash, again same as Java. And then if you come here, basically what you do is you use double backslash and write something. So anything you write after the double backslash is completely ignored by the compiler and it doesn't get printed. Okay, so this example uses currently a double backslash single line comment. So anything after this is completely ignored. Then there are something called multi-line comments as well. Multi-line means anything that uses backslash static, and then it can have multiple lines of code and then static backslash. Again, if you're coming from Java, exactly same thing. So this basically means I can have a multiple lines of comment. This can be 2 lines or 20 lines. Anything that comes between backslash static and static backslash is completely ignored by the browser, or by the compiler, sorry. Now, why we need this? Well, again, when we're writing code, we can block out certain piece of code that we don't want to be printed out, block of certain instructions or function, anything that you don't want compiler to execute. This can be a code, which can be your own comments, which can be instructions, and so on and so forth. Okay, you can write this multi-line in front of the text as well, just like we have here. Println has a comment in front of it. It can come in front, it can come in before, it can come in after, doesn't really matter. Anything after the double backslash or static backslash static becomes completely ignored. That's what comment basically means. So anything you write there as an instructions or a code or something you want omitted out, well, comes inside the comments. Make sense? Perfect. In previous session, we have been getting into the introduction of Kotlin, and we have seen how we can use Kotlin in our programming, along with what are the syntax, the output, and the comments. Today, we're going to talk more about variables, data types, and operators. Okay, so what exactly are variables? Well, variables are basically containers for storing data inside your system, inside your programming. So whenever we have some form of data, in order to store those data, we need something called a variable, which behaves as a container. Okay, so to create a container or this variable in Kotlin, we use var or val. We use these two prefixes to determine that, hey, I'm creating a variable which will have certain values stored inside it. Okay, then we use the equal operator, which will define that which value is going to be assigned to this variable. The typical syntax follows that we use var, variable name, and then is equals to value. What is a variable name? Well, variable name is basically the name that we use to access this value. So you can have any value here, integer, number, decimal, string, character, and that value will actually be stored inside this variable here. This variable name has to be a variable that is unique, doesn't have to have space, should not start with a number. Okay, there are certain rules that we need to follow. So what we do is we use val or var, we define a variable name is equals to any value. How does this work? Well, for example, we can say that I have a variable name is equals to inverted quotation marks John. Now we use inverted quotation marks to define a string. String means any text that contains multiple characters is considered as a string written inside double quotation marks. So we say, hey, this is a value and this is my variable name. And because we have used var, it's telling us that, hey, I have this variable's value. This is going to be stored inside this variable name. Please use that. Make sense? Then we can use val as well, and we can say, hey, birth year is equals to 1795 or 1975, sorry. Okay. Again, it doesn't matter that for a string you're using variable or val. It's just same thing. There are two ways to define it. The difference between these two is that the variables declared with the var keyword can be changed and modified. So whatever you declare with a var can be changed, can be modified, where anything that you declare as well becomes constant and immutable. You cannot change it. This value can be changed, this value cannot be changed. It becomes a fixed value. So that's where the difference between var and while comes into play. Then once we have a variable, you can use this variable anywhere in your programming to work on this value. Okay, so we say, hey, print name and print birth year. So when we use println name, what we're doing is we're asking a print method, which is a default method that will print output on the console, and we're telling it, hey, listen, I want to print the value of this name. So whatever is the value stored inside this variable, please print that value. It's not going to print the name. It's going to print whatever is the value that has been stored inside here. Similarly, when we say birth year, we're telling it, hey, listen, I want to print the value of this variable. Whatever value we have stored inside here will actually be printed here. If we check out the code, you see that we have a printed information in form of John and then 1975. How these two values got printed? Because we have stored them in a variables. Then we asked println method to please print the variable value name. So the name is not printed, the actual value gets printed. So this name actually behaves as a reference to this actual value. This value is stored in a memory, and then this variable name actually points to that memory location where the data is stored. So when we access the name, we are actually accessing the memory location that contains this value, and that value is fetched and given to print method, which then prints it on the console. Make sense? A little bit, right? Okay, yeah. So if you understand the basics of computer, you know everything stores in memory before we can process it. So we have a value and it stores in the memory. So instead of directly accessing the memory, we use a middleman which is called a variable name. That's why we call them containers. Basically, they point to that particular memory location. And when we ask them to print it, it's actually printing the value that's stored in a particular location of a memory, which in this case is John. That's how it basically works. Now, variable types. Unlike any other programming languages, variables in Kotlin do not need to be declared of a specific type, i.e. string, text, or integer. Okay, to create a variable in Kotlin, you should just store the text and another that should store a number. Look at the following example. So we have a var name John. We have a val birthday 175. So what we're doing is we are storing a string inside a variable. We're storing a number or an integer number inside this variable value. So you don't need to specify what type of data it is. This data is then implicitly assigned and identified by the Kotlin itself. Makes life much more easy. But if you're coming from C++ or Java, you know that in C++ and Java, we need to explicitly define what type of data we are using. Since in Kotlin, it doesn't need to be explicitly defined. It needs this prefix var or val. Again, keeping in mind the difference between these two is very simple. Var can be changed. Val cannot be changed. So the value becomes immutable and fixed. That's the only key thing that we need to understand. Then, Kotlin is smart enough to understand that the John is string and 17975 is actually an integer number. So it implicitly automatically assigns the data types. So it means that there are data types in Kotlin, but you don't need to explicitly define them. Okay. So in this case, for example, if you do need to explicitly define them, you would use a syntax called var name colon string. Now what this is doing is now we are specifically explicitly defining that, hey, I'm creating a string data type. Now I'm telling my Kotlin that, hey, I'm using a string data type, but this actually adds an extra overhead of using this thing. Makes no sense, right? Because Kotlin handles it internally, so you don't need to actually use this. But at certain situations, you might just want to explicitly make sure, hey, this is of type string. You can do that. You can declare a colon and a string data type or colon or integer data type, specifying that you're using this data type value. Okay, makes sense? Perfect. Now notes on val. When you create a variable with val keyword, the value cannot be changed or reassigned, again because it becomes immutable. The following example generates an error. So if you declare a variable with val named John and then you try to change it, by changing means that we again use the same variable name is equals to and we change it to something else. This is what we call changing or updating the value inside this variable here. Because we have declared it as a val, this will generate an error for us. Make sense? Yes. So that's how we actually define. So anything that's supposed to be constant, for example, the value of pi. Pi is supposed to be constant, should not be changed. Hence, we use it as a val. And if you try to change the value of that variable, then it generates an error. So that's where we need to be a little bit careful of what exactly we're trying to do. Whereas when you declare the variable as var, you can change its value. So then if you know that you have a variable that's going to be changed, its value is going to be updated throughout the coding or later on in some part of the coding, then you make sure you use var most commonly. Okay, so when do we use it? Well, it's self-explanatory. Wherever you have to ensure that the value does not change, you use it as val, and wherever you are using just normal variables whose values can get changed, updated, modified later on in the code through whatever operations we're doing, please use it as a var variable. Okay, then displaying the variable's value, well, this is how we display it. Now in previous examples, we have just used the variable name here, but you can also concatenate it with another string inside the println method. By concatenating means we use a string, again inverted quotation marks. Now note that here this string is not assigned to a variable. This is just a direct string assigned to a println method. Hey, listen, print this hello text, but I also want to print the name here. So what we do is we close the inverted quotations, we use a plus sign, and then we add a name variable to it. Now here this plus sign behaves as an overloaded operator, means it's not going to do mathematical addition. In fact, it's going to do what we call concatenation or joining operation, meaning that it's going to join this string with this variable's value. Make sense? Yes. So here, because we are using string, it's going to do that. But if you change this string into something called a variable value, so if you have this variable and you change its value to, for example, only 34, which now becomes an integer number. Okay. So if I run the code, you would see that it prints hello 34. Okay. So the 34 value gets printed as it is, because now what it is doing again is it's taking the string variables concatenates it with this variable's value, which is again 34. So we are seeing 34 value. What if we change this hello to also, for example, 22? Now what happened is, because the first number is integer plus the second number is integer, what's going to do is it's going to actually perform mathematical operations. So the plus behaves very intelligently, and it understands that what type of data you are using. So if you use a string, it's automatically going to add in terms of concatenate it. And if you're using two integer numbers, it's going to go automatically and do a mathematical addition. In this case, now the number becomes 56 instead of printing 22 plus name. However, if you let's change it to a little bit more, and then we use hello, and then again we say, oops, where did we go? We say, hey, plus 22 plus name. Now what's going to be the output? Now what we're doing is we're saying, hey, we have a string, we add 22 to it because this is a string and this is a mathematical number, plus we have a name. These two becomes mathematical and this is string. So what the output is going to be expected? Let's run the code and see. Now you see the output actually is 22, 34 with the hello string. Now you will notice that it's not doing mathematical calculation like it did in previous example. In fact, what it's trying to do is it's just doing the simple string concatenation or joining. So the reason is because it found a string, so it assumes that this is also going to be addition. Because we are doing string, it's a different data type, integer is a different data type. So it takes the priority and says, hey, you might just be concatenating these two things. So it uses hello 22 and then it says, hey, I have another name. Now because it concatenated this thing as a string, this operation again becomes whole in form of a string. Hence, all of this is now considered as a string because you have used 22 plus name plus a string. Okay, makes sense? But what if we do something like this? So if I write println and then I say, listen, boss, what we're going to do now is we have 22 plus the name variable plus the string answer. Answer. Okay, now what's going to happen? Now because we have used the number first, then the number for second, and then the string, what it's going to do is it's going to think, I'm going to start from the left hand side, add these together because these two are integer numbers, and then it says, oh, I have a string. So it's going to add the answer of these two things with this thing. So now you see it has generated an error. Why? Because it says, hey, listen, I have a number and then I have two numbers. So I can do the mathematical operations here because again, from left hand side, these two should be number. But then I have a string. So now I cannot do a mathematical addition of a number and a string. So now the operations mismatch. Here the intelligence fails. Okay, here it says, this is not working properly because I cannot do mathematical addition. I need a string to do operations. So it's generating an error. In first case, there was no problem for us. But in second case, it is a problem for us. So in that situation, what we do is we make sure that we have proper syntax followed along. Make sense? So we need to be very careful of exactly how we're going to operate the thing. So it's saying is that none of the following candidates is applicable. You cannot do addition in this sense. So you have to have a string first, in this case, string first, and then do the concatenation. Make sense? Wonderful. Okay, so now obviously you can do the concatenation and assign it to a different variable. So for example, if you have two variables, first name called John, second name called last name, and then you can do first name plus last name. Because both of them are strings, the answer is applied on a full name as a concatenated string. So if you check out the code, see we get John Doe. Why? Because this is a string and this is a string. So we can add two strings together, it will create the one thing. But when we try to do a mathematical operation with a string operation, it creates a confusion. Okay, so in this case, there's no confusion because it takes the string and concatenates and concatenates and concatenates. It follows the structure, same concatenation operation is done. But in this case, from mathematics to concatenation creates a problem. You could solve it probably by using a brackets here. Okay, so if you use brackets here and then do run the code, this again generates an error. Why? Again, because it has done mathematical operation. So in a one single statement, you are trying to do mathematical operation plus concatenation. So it confuses the things. Same thing goes for here. So if I use this string here, print hello with the string first plus 22, and then I put these two things in parentheses, and we know from mathematics rule that anything inside the parentheses has a higher precedence. So it's technically gonna go solve this string first and then operate here. So what's going to happen is that it's going to solve this one first and it's going to do mathematical operation. take the answer, but then this mathematics cannot be concatenated because these are two different operations on the same line. So it's going to generate error as well. So we need to be a little bit careful about that as well. Okay. So now using numerical values, if that's what it's saying. So if you use numerical values, it's going to do mathematical calculations. This will behave as a mathematical operator. But plus needs to be very clear on the same line. So you cannot do two operations together on the same line. It confuses the Kotlin system. Okay. Now variable names, we just talked about this a little bit, but basically you have to follow the standard rule. You can use any variable names, but there are some rules. The names cannot contain letters, digits, or underscores. So your name must be alphabet. You can use numbers later on. So this can be like first name 1, first name 2, first name 3. This is allowed. But if you use the number and before it, the first character cannot be a number. This will generate an error for us. That's the first rule of naming variables. Then it cannot contain spaces as well, because now it becomes two different words. This again will generate an error. You can use underscore inside it here as well. Underscores are completely allowed. Okay, so your name should start always with a letter. You can also begin with a dollar sign or an underscore sign. These two are again perfectly legal characters, but we will not use it in this tutorial. Again, W3 Schools doesn't prefer that. Names are case sensitive, so my var and my var are two different variables, so do be very careful of that. These two are two different variable names. Because we have a capital letter here and we have a small letter here, this becomes two different characters. So the name should always start with a lowercase letter and cannot contain white space. That's again another rule. We just talked about that. The reserved words such as var or string also cannot be used as variable names. By that we mean that the value itself, val, is a reserved word. So you cannot have a variable called val, because now it confuses the whole guy. It says, hey, val, what's you doing? This should not be val. Yeah, you can do val1. Now it becomes completely different. But make sure you don't use reserved words. So there are some words like val, like function, like main, like string. These are what we call the reserved words. We will explore them as we go along, which are done by the system. So it says, hey, because these are reserved words, please do not use it in my variable names. Perfect. Okay. So now most conveniently, we use something called a camel case variables. What camel case means that if you are using two variables, two names, for example, first name, this becomes two word. So you join them together. The camel case is that the first letter is small and the second word that begins has a capital letter. So similarly, last, last, L is small, but the name, because these are two different words, we join them together. The second word will start with a capital letter. So it's like having a camel hump in the middle, capital letter in the middle. So that's why it's called a camel case naming convention. This is a standard naming convention that we follow in programming nowadays. So even if you are using multiple characters like my favorite food, what you're doing now is the first letter is small, the second letter becomes capital letter, and the next word again becomes a capital letter. So it's like two hump camel. Okay, so every time you are using multiple words together, make sure the new word, it's not a rule, it's just the convention that you follow. Make sense? Perfect. Let's talk more about data types now. So now let's talk about Kotlin data types. One, data types basically define what type of data we are using within our programming. In this case, Kotlin. Now, in Kotlin, we have various different types, including integer, which basically represents a number form. A double is known as something that has a decimal value. Then we have character, which represents a single character inside a single quotation marks. Boolean are data type that only contains two type of values, either true or false. And we write the word true to indicate it's a data type true. And we write false to indicate the data type is of false. Similarly, we have string. String is represented with number of characters in double quotation marks. The difference between string and character is that character contains only one single character, whereas string contains multiple characters. All of them are declared using the variable val. Okay, so we define the prefix val and we define the variable and the data type. All these are implicitly automatically assigned to this variable mynum or whatever variable name you're using. So data type technically in Kotlin are implicitly assigned, but you can explicitly assign them as well. To do that, we use colon and then type of data. So for example, if you want to explicitly tell that, hey, I'm creating an integer data type, you need to define val. Again, the same prefix goes, the variable name, any name that you can use. Then we use something called colon and integer 5. This defines that we are using an integer of type 5. Then similarly, if you're using a double data type, you use colon and double. This indicates, hey, I'm using a double data type. And then if you go for character, similarly colon character, colon boolean for a boolean data type, and colon string for a string data type. This basically means that you are explicitly telling Kotlin that you are declaring a type of data that is of a particular data type, whichever you are using here. Okay, so this is what basically means. So in Kotlin, we define these 5 data types. Numbers, well, numbers are types that are divided into 2 different groups: integer numbers and floating numbers. Integer numbers basically have valid types called byte, short, integer, and long. These actually are same depending on the memory size we need. So it basically is a number, okay, but it has 4 different types: saying byte, short, integer, and long. And these 4 actually differentiate with respect to the how much memory is allocated to a variable or a data type. So byte takes only 1 byte in memory, short takes 2 bytes in memory, integer takes 4 bytes, and long take 8 bytes. Based on that, the values determine how big a value can go inside this or not. So for example, when you declare a data type of type byte, it basically means that it has only 1 byte in memory. Hence, the maximum value it can go is from -128 to 127. You can only specify a value between these two numbers because it only takes 8 bits in memory: 1111 and 1111. So if you set all bits to 11111, if you convert it from binary to a decimal value, you will get 127. Make sense? Okay. Similarly, if you take up short, basically now you have a short variable and it takes 2 bytes in memory. Because it takes 2 bytes, now the range of value that you can store inside this variable increases from -32 to 32,000 to approximately 32,000 positive. Okay, so that's the range of value you can go from minus to positive value when you declare a data type of short. It again contains an integer, basically a number, but if because it's of type short, it takes a less memory. Byte takes only 1 byte, short takes 2 bytes, and then typically we use integer. Integer basically takes 4 bytes in memory, hence you have a huge range of value you can take. So 4 byte means 64 bits, and then you can store a very large value inside a 64 bit. But in certain cases, you need even more bigger value. So for that, you take a long. And then long, because it takes 8 bytes in memory, means that whenever you declare a variable explicitly as long, it can take a huge value between these two ranges. Okay, so if you need a very large calculation or very large data processing and a number needs to have a huge value in trillions, then it's always recommended that you go for long. But here's something that you do: is optionally you can end the value with L. Okay, so if you don't declare a variable data type explicitly, implicitly you need to write L word at the end of the number. This will indicate, hey, I'm using a long variable. That's another thing that you need to remember. So whenever we're declaring a long variable, what we need to do is we need to tell our value itself that, hey, it's still a long variable even though we have explicitly defined it. So this L here is a prefix, postfix, sorry. This val is prefix, my name long is equals to, we define a value, and then as a postfix means something that comes after the value is L. Okay, the difference between integer and long: the whole number is an integer as long as it is the normal value. If it goes beyond that, it is a long value. So whenever the value goes beyond this variable value, the maximum range, the Kotlin system automatically considers it as a long. Again, remember this L is optional, but it's sometimes recommended to let the user know that, or the developers in the team know that you're using it. Then we have a float value. Anything that goes with a float and or a double, again, is a decimal value. But then again, these decimal values have 2 types: floating value and a double value. Similarly, floating also takes around 4 bytes, and then double takes 8 bytes. So that means, again, if you need a very large number in decimal values, you go for double. Because default is double, hence we explicitly need to define F to tell it, hey, this is a floating value occupying a less value. Okay, so my name colon float is equals to 5.75, and then if you specify it F, even though it's a smaller value, but it still needs to have this F value. Double doesn't need have that prefix. Okay, so the precision of a floating point value indicates how many digits the value can have after the decimal point. The precision of float is only 6 or 7 decimal digits, while the double variables has a precision of 15 numbers. So meaning that if you have this precision 99, for this floating value you can have maximum of 6 or 7 precision decimal values, whereas double can have up to 15 digits of decimal value. So after this decimal value, you can have up till of 15 values after the decimal point. So long range of values you can specify here. That's the key difference between double and that. Okay, so these are basically simple data types, creating of a boolean only containing either true or false. We have a character that only contains a single character. We have a string that takes on a string in terms of number of characters that you specify in a string. Then we have something called arrays, because arrays are basically used to store multiple values in a single variable. So instead of declaring each variable separately, we create an array where multiple values are assigned to a single variable value. You'll learn more about this in arrays chapter later on in the sections. Now, type conversion. What do we mean by type conversion? This is something quite important every time we use programming. Type conversion means that we convert one data type into another. Okay, so type conversion is when you convert values of one type of data to another type of data, and this is more often used than you might think. So in Kotlin, numeric value conversion is different from Java. So if you're coming from Java, you might find this a little bit different. It is not possible to convert integer type to a long type with the following code. So for example, if I have integer 5 value and then I declare x is equals to 5, this will give us an error. Typically in Java, this would be allowed because integer takes 5 bytes and 4 bytes and long takes 8 bytes. So the rule basically here is that a smaller memory occupying value can easily go inside the larger value. So in this case, integer 5 can easily go inside the integer long because it should be 4 bytes and this is a larger byte, but this is not happening in Kotlin. Okay, to convert a number data type to another type, you must use of the following. You need to use something called functions. So these pre-built-in functions define us what type of conversion we want. So when we use to byte, name is suggests you want to convert data type to byte or to short or to integer or to long or to float or to double or to character. So these are various different built-in functions provided by Kotlin that allows us to do the type conversion. Okay, or in other words, some programming call it casting, meaning that whenever you want to convert one data type into another, you need to use one of these functions depending on what type of data you want to convert. So in this case, if I have integers equals to 5 and then I want to convert it into long, I cannot just simply change this variable value from like this will generate an error. I have to use x dot to long. So now x is a variable and I have to use x dot to long function. So that means that I want to convert this x variable to the long value. Hence, then now the value will be casted back into this y variable. This is perfectly allowed. Okay, so this is what we do. So anytime you need to convert a value, basically you need to use this thing. Make sense? Perfect. Okay, so yeah, you do need to remember these functions as well time to time. And as we start to use them, we start to memorize them automatically. We just need to understand that there's a function called to byte, to short, to characters. Whatever data type you're using, to small be capital or the second word becomes capital in all these cases. Make sense? Perfect. Let's go into operators a little bit and then finish this off quickly. Now, what do we mean by Kotlin operators? Operators are used to perform operations on variables and values, similar to plus, minus, multiply, divide. That's what operators are. Every programming languages has these operators, and this is what we're talking about here. So whenever you use 100 plus 50, basically we are using plus, which is known as an operator. Okay, and there are various different types of operators available in Kotlin, such as arithmetic operators, assignment operators, comparison operators, and logical operators. Arithmetic operators are known as simple mathematical operators such as plus, minus, multiplication, divide, modulus that returns a remainder, plus plus, which is basically an increment operator. It also has a minus minus, which means a decrement operator. These are all known as simple operators. The way we use them is we have two variables, plus them, two variables, minus them. You can use the values directly here, variable plus a value, variable minus a value, depending on how you want to do that. But these are all a standard way of how we want to basically use them. Then we have Kotlin assignment operators. Assignment operators are used to assign values to a variable, okay, just like equal to. Just like equal to. Okay, so when we say variable x is equals to 10, we are actually using this assignment operator, which means that assign the value 10 to this variable x. This is what assignment operator does. But then there are various other additions to it, such as plus equal to. What's plus equal to? Well, plus equals to basically means that take the value of x, add plus to it, and then assign the answer back to x. Okay, so if I come back here, you see this table at the bottom. What it's saying is that, hey, listen, we have a variable equal to, which basically assigns a value of 5 to x, or whatever value we have assigns to it. But then there are a few other operators as well. These are known as, again, more shorthand assignment operators, which basically says plus equals to, minus equals to, multiply equals to, divide equals to, and modulus equals to. The way we use them is we say variable x plus equals to 3. What this represents is, or what this expands into, is that take the value of x, add 3 to it, and then assign it back to x. And this value can be any value you want. So if you use 2, 1 plus 5, then it basically means that take the current value of the variable, do the operation, and then assign it back to the same variable, so overriding its value. Similarly, minus is equals to 3 means take the current value of x, subtract 3 from it, and then assign it back to x. Take current value of x, multiply 3 to it, and then assign it back to x. So basically, we are overriding the variable. So you can write it in this way, or you can write it in this way. So this is exactly same expression. This basically means same thing. That's why we sometimes call them shorthand operators. Shorthand means we just shorten the code, and we don't have to write a complete line. But this is more simple form of notation. This is more advanced form, quicker assignment operator. Then we have a comparison operators. Comparison operators are basically where we start to make logical decisions. They do comparison and they return something called a Boolean value, which is either true or false. The answer of these comparison operators are always in Boolean form. That's where we have a Boolean data type. So we know that what type of answer we are getting. So Boolean data type is actually seems very simple, true or false, but it's extremely useful and extremely commonly used. Because, for example, whenever we use a relational operators or comparison operators, we are checking a relation between two variables. And the answer of this relational valuation is always in form of Boolean, either true or false. So, for example, when you use double equal to, it means we are comparing the value of two operands from left hand side to right hand side. So, it says x is equal to y. So, we are now comparing the value of x is equals to y. Similarly, not equal to, which basically means that the value of x is not equal to value of y. Okay, so this is now an inverse equality check. Then we have a greater than sign. Greater than sign means that value of x is bigger than the value of y. If the answer is true, it returns true. If the answer is false, it returns false. So if you check into few of these programs, now, for example, we have this thing. So we declare fun function main. Again, remember every program has to have this thing. We use variable x is equals to 5. We use variable y is equals to 3. So we declare two variables. Now we want to compare their value. So we use print statement here. X is greater than y. So what it's going to return? It's going to return true to us. Why? Because the value of x is 5 and we are comparing it with the value of y with using this greater than symbol. So this greater than indicates the value of x is bigger than the value of y, and it returns either true or false for us. So if we change this value, for example, if I make this 13 and run the code again, now guess what the answer is going to be? Yes, now it will return false to us because x is actually 5 and y is 13. So the value of x is smaller than the value of y. Hence this comparison is going to give false for us. Make sense? Similarly, we go less than. So now we are comparing the value less than that. So when we use the less than value, it tells us that, hey, the value of 5 is less than 3. So it's false because 5 is x is 5 and value is 3. So 5 is less than 3. Okay, so this becomes false. Yeah, if you change the value of this again to a higher number, then it's going to return either true or false in that relevant case. Similarly, greater than equal to, which basically means that, for example, if you have value both exactly being, say, 5 and 5. Now, if you use this comparison, what we're going to get is we're going to get a simple false value. Why did we get false? Because x is 5, y is also 5. Technically, they both exactly the same value. So if you use equal to operation, we should be getting true. But because we are using greater than, so we are checking here that the value of x is actually greater, or we can say bigger than the value of y. In this case, the condition becomes false. Now, here's another thing. Even though if you use less than, this will also return false to us. Why? Because again, this indicates value of x is less or smaller than the value of y, which again is not the case because they both are equal to. So in certain situations, we want to evaluate with this equal to operator. Now, what this equal to means that the value of x is less and equal to. So now we are doing two comparisons in one thing. So this is again a shorthand operator that evaluates two conditions. The value of x is smaller and equal to the value of y. In this case, this will return true to us. The reason again being because we have used equal now it's going to do the two comparisons. Either it's small and it's equal to. Okay, so this would make sure that we have either same values or a smaller value. So we get a true value here. That's what basically we do in these equal to and greater than symbols. Then we have something called logical operators. Okay, the logical operators are used to determine the logical between two variables, or logic values, or logical relations between two conditional values. In other words, there are situations where we want to evaluate multiple conditions at the same time. In this case, we used greater than equal to. Again, two conditions were evaluated. But here we use double AND operator, double pipe sign, as it call it in your keyboard, single two bars, and a not logical. The way we use them is we use one expression, x is less than 5, and x is less than 10. So now we are evaluating two different conditions, whether the value of x is less than 5 and the value of x is less than 10. Similarly, x is less than 5 or x is less than 10. Now, how the way it works is that when we use the AND operator, in order to statement to be true, the value has to be true on the both sides. So for example, now what we're doing is we're saying, hey, the value of x is bigger than 3 and the value of x is less than 10. So basically we are checking a range between 3 and 10. Okay, so what we're saying is that the return true because 5 is greater than 3 and 5 is less than 10. So we are checking the value between 3 and 10. So when we need to check a range between a certain statements, we use the AND operator. So AND will only return true if this both conditions, both sides are true. Okay, so technically AND needs true on this side and true on this side. So we use two comparison statements, return true, and then the AND will give answer to us. If either one of them becomes false, the condition becomes false. So for example, if I change it to 15, now this becomes false. Even though the first condition is true, x is greater than 3. Yes, x is 15, so it is actually bigger than 3. So this will return true to us. But because x also has to be below 10, now this becomes false because f is actually bigger than 15, or the x value is 15 bigger than 10. So this is going to return false for us. So the first part, the left hand side is true, the right hand side is false. Because they don't match, the answer will become false. Make sense? Yes. Similar to that, the opposite end is true, OR operator. What OR operator does is it gives us the OR value, just the name suggests. Either x is bigger than 3 or either x is less than 4. In either situations, the condition becomes true. So if see this, we have x is 5. Now what's happening is that x is greater than 3, condition becomes true because again, it's bigger than 3, right? But since we have a second condition that says x needs also be less than 5, in this situation, the condition becomes true. Why? Because OR operator requires either side to be true. The AND requires both sides to be true. For AND, they both have to be true. For OR, either one of them has to be true. That's where it comes into. That's why when we use AND word, it basically means both sides, left and right side, have to be true. For OR, only one of them have to be true, and it just works with that sense. Okay, so this is what we do, and not actually turns the true into false and false into true. It just inverses the results. It reverses the results. So if the conditions is true, it will make it false. If it's false, it will turn it to true. Okay, more about these when we go into if else statements, because actually these relational operators and these analogical operators we use in hand and with if statements, where we may actually make a conditional decision based on these relational statements. So either these relational statements and we combine it with them to make it more powerful condition. So technically we're using this and then we combine it with this and or not to make a more powerful and very concise range based decisions. And then once the decision is made based on true and false, certain statements are executed using again if else statements, when, while, then looping statements as well for that matter. Okay, so we're going to talk more about this in next sessions. Now, what do we mean by strings? Well, strings are basically called collection of similar characters. So a string is a collection of characters surrounded by double quotation marks. So whenever we want to use a string, we use number of characters that are encompassed inside double quotation marks. That's a simple string for you. In Kotlin, in order to create a string, again, you use a prefix called var. You define a variable name is equals to quotation start, string characters, and quotation close. This is their simple predefined string. So unlike Java, you don't have to specify the variable type to be of string, as we have already discussed this in previous sessions. Now, Kotlin is smart enough to understand it because it implicitly automatically assigns the data type string to whatever you write inside the double quotation marks. Make sense? So you can explicitly define it though. You can use again prefix var, greeting, colon, string. Just like other data types, you can specify colon string to make explicitly define that, hey, I'm creating a string type data. Okay, this can also work fine, but usually you don't need to. As I said, it automatically does it for us. So now, if you want to create a string without assigning the value or assign the value later, you must specify the type declaring the variable. So for example, in this case, if you are using var name string, this means that I am creating a variable called name, but I don't want to specify value right now because the value could be initialized later on from the database, from user input or for whatever not. In that case, because we are creating a variable and not specifying any type, now it's mandatory that we do specify explicitly what type of variable it is going to be. And then name is equals to John means later on in the code, we can specify the value to it. So if that is the case, we need to ensure that you do explicitly define it. So if you don't define it, this is going to generate an error because at this moment, it doesn't know what type of variable I'm holding because there is no value there to implicitly assign it to this guy. Make sense? Yeah. So this is where actually this explicit assigning of a data type comes into play. In other programming languages like Java, C, C#, we always use a data type. But here, we don't need to do that. It's implicitly done. That's why if you need to declare a variable without any value, make sure you do that. How do we access a string? Well, accessing a string basically means that we access individual character items of a string. As a whole, when you use this variable like name, it is actually accessing the entire string. But because this is a collection of character, you can easily access individual characters as well. The rule is simple. Every character that you declare inside a string has a specific index number. Okay, it's like a page number. So it identifies that, hey, this H is actually on 0 index. Then E is assigned on 1. The index number always starts from 0. Okay, so all the index numbers in a string always, no matter which string you create, every string is assigned a 0 index number starting from the first character, and then subsequently every character is given a sequential number every single time in every single string. So that means that if I want to access the first character, I can write text square brackets. Inside the square brackets, I use an index number 0. What I'm doing now is I'm accessing an individual character from this entire string. This allows us to process string characters. This allows us to do operations on string. This is where our NLP and other languages start to kick in, where we can perform various different operations on our string, whether which character it is, identifying words, tokenizations, and so on and so forth. So for example, if I write txt, again the variable name, square brackets are important because square brackets technically indicate an array. Array means collection of data type, which again is a string. So this is actually representing an array, and defining within it is a number, which is actually the index number. So here when we specify 2, it's actually accessing the second index character, which again in a sequence is the third one because it's starting from 0, 1, and then we have 2 characters. So when you execute the code, you would see it will print H and L. So we define a function main. Again, remember every code goes inside the function main. We define var text hello, print 0 index character. So it prints H. Then we say print L and 2 character index. Then it prints L because this is here. So whatever string you write, you can access individual characters as well. String length. Because it's a string internally behaves like an object. Okay, because it's a string collection of data, internally it handles this thing as an object, which contains properties and functions. So that means that you can use multiple different functions on this string. So in simple sense, we can use something called a length function. What it does is that, for example, if you have a string and you specify a longer string and you want to know how many characters are there in this string, we can very easily say print the length of the character plus txt dot length. So now what we're doing is we are using the variable name, which is txt dot operator, which is a connection operator. It connects one object with its methods. So it behaves like a connection operator, like a bridge between two different things. So the first thing is actually the object, and for that object, its relevant method. Okay, so it connects the method with the object, use this dot operator, very important. Then we have a predefined method. So the good people have already declared the method. We all need to do is just call this method. So we say text.length. What this is going to do is it's going to count all the characters inside it and return the total length of this thing. So whatever string you have, you can find out how many characters are there. So in this case, we have 26 characters. Okay. So in this case, we have 26 characters that are existing here. So whenever we need to find out how many characters are there, you just use this function. Similarly, there are other functions as well that you can use with the strings, such as uppercase, lowercase. Now, this means that I can use txt dot uppercase. What this will do, evidently, it will convert entire string into an uppercase. So the output will be hello world. Or you can use the lowercase method as well. This will again, vice versa, will convert the entire string into a lowercase. The only key difference now is that
notice the length doesn't have a brackets, whereas these two functions we have used have a brackets. Okay, that's a key difference, sometimes confuses a lot of people. Length is actually an internal function of an array, and so sometimes certain arrays are not considered as an objects. That's why this function is there without brackets. It is a function, but it's like an internal built-in function, not explicitly declared. So this is like an explicitly declared function that has this round brackets. This is an internally defined system function, if I can put it in the right words. That's why it doesn't have it. So most typical languages, even in Java and C Sharp, I've identified that the length function, you can use it without the brackets. So because it's not explicitly declared, these are actually explicitly declared in a string class, and that's why they behave like a typical normal function. So we call them using the txt dot uppercase with the round brackets, and similarly dot txt lowercase with the round brackets. So they behave like a normal declared functions, and this is what we call a function call looks like. More about functions later on in the session. Now comparing strings. So since we have these two functions, there are again numerous other functions as well. One of them is compare functions, which is again very commonly used. This is used to compare two strings together, whether these are equal to each other or not. Okay, so we say, hey, I have a string called txt1, I have another string called txt2, and I want to compare these two strings together. We can't do just simply equal to comparison in this case, like we discussed in operators. Equal to comparison works with numbers, decimal numbers more appropriately. Single characters, yes. But because this is an object that has character array, means a collection of characters, you cannot do a direct equal to comparison. That's why we use a specifically declared method called compare to. And then we say, hey, text1, take the string in text1, compare it to text2. So it's going to compare these two strings together, and then it will return an answer to us that whether these two strings two are equal to each other or they are not equal to each other. So if they are equal, outputs 0 because they are equal, and if they are not equal to each other, they will return 1, which basically means that any other number will indicate that, hey, they are not equal to each other. Make sense? Yes. So whenever we need to use these functions or compare these things, we use these functions called compare to. Then finding a string inside a string, again another function is called index of. Index of is a function that actually does the searching for us. So it's like a search function. So it does that, hey, I have a string called text dot index of, find me the index of the character locate. So we have a locate string here inside this, and we want to find which index this locate starts from. So when you do that, you see it returns 7. Why 7? Because again, starting from 0, remember index numbers always start from 0. So we say, hey, 0, 1, 2, 3, 4, 5. Even the space character is a character. It doesn't have a visual representation, but technically it is a character and occupies space in memory as well. So this is again a space character. So this also has an index number. Do keep this thing in mind. So this is our 6th index, and then the 7th. So it returns the first occurrence of this character. So wherever the first occurrence is, it returns the 7 index, indicating, yes, I found the character, and it starts from the 7th one. Make sense? Wonderful. So similarly, there are other functions that you can use and explore, and there are many other things that you can find out within strings as well. Let's talk more about Boolean now. Okay, similar to string is a collection of arrays, and it has characters and everything. Boolean, on the other hand, is a completely different type of data. What it holds is only two values, either true or false. That's it. It's considered as a 1-bit variable or 1-bit data type because it only occupies either 1 being true or 0 being false. That's the only value that you can store on it. Some programming languages call it yes or no, on and off, or most commonly true and false. So even if you're coming from Java, C Sharp, C++, most of the time you would find that we use the word true and false most commonly in programming. Some people tend to use on, off, yes, no, some kind of a thing like that. But yeah, this is something that you would go for most of the time. So this basically means that every time you declare a variable, is Kotlin fun, colon Boolean, again, not necessarily, but you can explicitly define it, and then you can say true, or you can say false. That's it. So these are the only two technical values that you can use it. Now do keep in mind, even though we are using TRUE, 4 characters, it only means it holds 1 bit in memory. So it will only save actually one thing. So instead of using 1 and 0, we use the word true and false. And these true and false are actually keywords. So the programming or the compiler of Kotlin recognizes true as being 1-bit value and false as being 1-bit 0 value. That's it. So that's why even though we are using characters, this whole word, see this, it doesn't have a quotation marks around it. It's a keyword. It's a reserved word. Kotlin recognizes this as true and false, either in terms of 0 or 1 with the respect to memory. So when you use this, it just prints true and false. Why we need this variable only holding true and false? Because again, we talked about comparison operators in the previous session. Every comparison operator compares a value and then it needs to return an answer in true and false. So when they return an answer, the answer has to be saved in a memory as well, because we know that when the computers work, everything internally is saved inside a memory. So when you save something inside the memory, you need to tell the system and the processor that what type of data we are saving inside the memory. The memory needs to know that what type of data I'm holding. Okay, so based on that, it operates and it works internally. So even though when you're doing comparison, the answer is returned either in true and false, or in more specifically in 0 or 1 form. So we need to tell our processor and our memory management that, hey, I'm storing a value called 1 bit true or 1 bit false. Make sense? So that's why we need to explicitly define and have a data type called Boolean, and that's why every programming languages has a Boolean, so that you can specify and specifically tell your memory that I'm not storing 1 as an integer number, I'm storing 1 as a 1 bit true value or 0 as a 1 bit false value. So the memory knows that now what type of answer it is holding, and based on this Boolean answer, we then use if-else conditions and when loops and while loops. Okay, and even for loops. All these other syntaxes actually use Boolean values. They make decisions based on these Boolean values. So Boolean is one of the fundamentally most important data type, because then it allows us to make decisions in our system. Make sense? So you can use all the comparison types. Every time you use a comparison operator, they return either true or false. So if you use greater than, it returns true, which is basically meaning the condition is true. If it is false, the condition becomes false. Okay, so that's why we have a Boolean data types in our system. Will that make sense, right? Perfect. Okay, so now let's go into more actual technical thing inside Kotlin. That's called if-else. If-else statements basically allow us to make a logical decision. Okay, now we have talked about the logical operators. Using these logical operators, the if-else statements allows us to make a logical decision. By decision, we means that if we do a logical comparison, then we make a decision either to follow, if the condition is true, what to do in that situation, or to follow a second path where if the condition becomes false, then what to do. So it's like it gives us a choice, it gives us an option that you have two ways. You take, if the condition is true, you go to the right side. If the condition is false, if the logic is not working, then you can go on the left side. Typically, up till this point, the program usually has a single linear flow, means everything executes line by lines. Whatever you write gets executed, next line executed, third line executed. If else actually allows us to do a branching within our code. By branching means that we have a two bidirectional binary branch that based on this if else statements, whether you want to go to the left side or you want to go to the right side. So now we have two paths to take. Okay, that's why the if else statements are more important, because this logically decision making allows us to make our program more complex and do a real world tasks based on the decisions and the user inputs and the data that we gave it to it. So if else has various different structures, but first thing foremost, if else do rely absolutely on these relational operators. So you need to understand them again very clearly. We have less than operator, which basically means it evaluates left hand side with the right hand side. The value of left hand side is less than the value of right hand side. Less than or equal to means the value is less and equal to the value of b. Similarly, greater means value is bigger and equal to b. Bigger than b, and equal to means bigger and equal to b. Okay, so greater than equal to, less than equal to, less than equal to, and all these operators work in a similar logical manner. Equal to itself will compare the two values directly each other, and then not equal to is actually inverse of equal to, means that it is a is not equal to b. So it's like an not checking in an inverse manner. Okay, so we will be using this regularly throughout our if else statements. Now Kotlin has these following if else condition structure. We use if statement individually. We can use else statement, but else doesn't is not allowed to be used individually. Else has to be used with if statement. I'm going to talk about this in a moment. Then we have something called else if, means that we use if statement, and then inside the else statement we can provide another branching. Okay, so this is where the nested if else concepts comes into play. So we have a branch inside it, again we have another branch inside it, we can have another branch. So we have a multiple nested structure following it. Okay. So unlike in Java, if else can be used as a statement or as an expression. to assign a value to a variable inside the Kotlin. Now, this is quite important thing. In Java, typically they only use the comparison statements and they do the branching. However, in Kotlin, these can be used as a statements, or as we call them, expressions. Means not only make a decision based on that, they can actually return a value and assign a value to the system as well. How to do that? I will talk in a moment. Okay. So see an example at the bottom of the page. So we'll talk about this later on. Now let's talk about Kotlin if. Now if is a specific we use if to specify a block of code to be executed if the condition is true. This is where the first initial branching occurs. Okay, so this means that we write if statement, bracket start, bracket close, and we then specify a condition. Now this is the condition. Keep in mind this word. Whenever we talk about the word condition, we actually referring to these words here. Means we write some form of logical comparison that return either true or false to us. So this condition actually means if actually needs true and false. It doesn't need these things. But the only way we can achieve true and false is through this thing. Okay, so keep it in mind that if condition doesn't need these operators, if condition actually requires true or false. If it returns true, it will execute the block of code. If it returns false, this block of code is completely ignored by the compiler and not executed, and these lines are skipped. Make sense? So this condition, the only way to achieve true and false is using these relational operators. Okay, so all these comparison operators can be used to achieve, or any one of them or combination of them to achieve that true and false. So that's why we actually associate with this thing. Okay, so now if statement is the if is in lowercase letters. So if you write in capital letters, it will generate errors. Be careful of that. Again, we've talked about it in previous sessions as well. Kotlin is case sensitive, so do be very careful about that. Now, in the example below, we test two values to find out if the value is greater than 20 and less. So what we do is we say, hey, if the value 20 is bigger than 18, you need to print the 20 is greater. Now this is where the branching comes into play. We are using comparison operators to check whether this value is bigger than this value. If the values are bigger, we know that the comparison operator will return true or false. So if it returns true, this line of code will get executed. If it returns false, this line will be completely ignored. That's what the true if condition allows us to do. So we have 20 greater than that. So for example, if I make it 180, so this is run. Now what happens that 20 is greater than 108 because the condition is false. These lines will be completely skipped and there will be nothing on the output. Okay, so we have no output at here. And then because again the condition is false. So this is where the branching comes into play. We write a block of code and block of code ends. So this curly brackets indicate the block of if. If the condition returns true, if this becomes true, only then the if block will execute. If this becomes false, this entire block is completely ignored and nothing gets printed in this case. Okay, so this is what happens now. So we can have two variables do the comparison, same thing. Okay, so in this example, again, we are using two variables to do the comparison. So we check the left-hand side value if it's greater than the right-hand side value. If the condition returns true, this gets executed. If it doesn't return true, this gets completely ignored. That's where it does. Okay, then we have something called else statement. We use else to specify a block of code to be executed if the condition inside the if becomes false. So this is where the second branch comes into play. In the previous example, there was only just one branch that you execute the code, if check a condition, if it is true, execute this block of code, otherwise just go the normal way. But this is now the way we call the binary branching comes into play. Means we have now two conditions. If the condition becomes true, execute this block of code and ignore completely this block of code. So the else is completely ignored in this case. So when this condition is true, these lines will get executed and else is completely ignored. However, if the condition becomes false, now the if condition is executed and the else this line is completely ignored. So now we have two blocks, two branches. True, execute the if, else execute this thing. Make sense? So this is where times come into play. Let's look into the example here now. So for example, we have this thing, function main, we define a value time and then we define a condition. So what we're now doing is we say, hey, time is equals to 20. Okay, so if time is less than 18, print have a good day. Okay, so we're now printing this thing and then we have a block of code here. So if the condition becomes true, execute this line. But then because we are making sure that the condition is true, we need to execute this block of code. Hence the else statement are completely ignored. Okay, so these lines are now ignored. This is where the branch comes into play. In cases if this condition becomes false. Okay, so for example, if time is less than 18, we say no, let's just make time, for example, 2. So, oh, sorry, let's just make it in fact 23. So now the condition becomes false. Because the condition is false, now the first line or the line inside the if block gets ignored, and automatically it will execute whatever you write inside the else statement. So else will execute automatically because the condition is false in this case. Okay, make sense? Yeah, so this is where the branching actually comes into the play. Now we have what we call else if structure as well. This is nested if else structure. So what this specifies is that little bit more complex now. We're saying, hey, check the condition 1. Okay, if the condition 1 is true, execute the block. Everything outside after it is actually completely ignored. So all these lines are ignored because the condition becomes true. So I need to execute these lines. That's it. The first branch. The second branch is that if the condition becomes false, then go inside else. But inside this else, we have another if condition. So this is again a nested if else structure where we have else. So this means that now because the first condition is false, I need to execute this, but it also now contains an if condition. So it's again going to check the if condition. If this condition becomes true, it's going to execute this line of code and ignore the next else. This line will be completely ignored. So this is like the third branch. But if this gets false, only then in this situation, this line gets executed. Little bit sense? Let's look at the example to get a better idea of how this thing is working. So let's look at the code. What we're doing now is that we have a variable called value 22. Okay, it contains value 22 time. Okay, so we say time less than 10. The condition becomes obviously false because this is 22. So this line is completely ignored. Then we say, hey, else if. So now we have nested if else structure. So we again checking if the time is less than 20, then print have a good day. But because the time is 22, again this condition becomes false. Because this condition becomes false, now it's going to go to this else and print good evening. If I change it to, for example, 18 and print, so now it's going to say, hey, time less than 10. This becomes false. So this line is completely ignored. But at the same time, because now time is 18, so it's going to check this second condition. This condition becomes true, it's going to print good day and ignore this line here. So based on whatever condition we write, the branching occurs. So if the time is again just simply 8, so now if I execute the code, because the first condition becomes true, it's going to print good morning, and all of these lines are ignored completely by the compiler. Only the first line executes and the control goes outside the block. See, good morning, all other things are completely ignored. So this is where if-else conditions actually play a vital role in making a key decisions within our systems. So now what do we mean by Kotlin expressions? Okay, so we talked about just initially that Kotlin, you can also use if-else statements as an expression, assign a value to a variable and return it. So how it is work is that you can use, for example, value 20. We can say, hey, variable greeting. If the condition is true, block good day, else good evening. Now notice here that in previous example, we did use println statements, bracket start, bracket close. This time, we're just using a string without any round brackets. Why? Because this time we have specified that, hey, I'm using an expression. By that we mean that I'm telling it that, hey, if the condition is true, return this value to this greeting variable. Okay, return this value and assign it to the greeting variable. If the condition becomes false, then go to the else statement and return this else and assign it to the greeting variables. Whatever you have written inside here, this single value, it has to be a single value, it needs to be assigned to this thing. Okay, you must also include else if you are okay. So this is warning level coming up. So what this basically is doing is it's assigning value to here, and then you can later on print the greeting value depending on what you want to do it. Okay, so now here this, when using if as an expression, you must also include else. So whenever you're using if as an expression, else has to be there. In a normal case, you can write if only, you can write if else or nested if else structure. But if you're using it as an expression, what we're doing now is we're saying, hey, execute the condition. If the condition becomes true, assign this good string value to this variable, because we are using equal to operator here. So whatever we return, and because we are returning, we don't need to use println, and it has to be a single line so that the single value can be assigned to it. You cannot have multiple lines of code here. And then similarly, it has to have else statement. So at any given moment, one value will be assigned to it. So if it's true, good day will be assigned. If it is false, this value will be assigned. So no matter what, based on the condition, their value will be assigned to this. So that's why I say else has to be there. You can omit the curly brackets when using if only statement. So you can actually use it in a single line as well, which actually is the more common way of doing it because it only contains single value. So you actually use it, hey, if time is 18, assign a good day, else assign a good evening. This makes a little bit more sense. So this actually means that take the value of good day, assign it to the greeting, or if the condition is true. Else, assign the value of good evening to this greeting. Okay, so this becomes our single line if else statements. Make sense? Perfect. So now next we will talk more about when. Now, instead of writing if else expressions, you can use when expression, which is much easier to read. It is used to select one of the many code blocks to be executed. If you're coming from Java, C Sharp, or C++, you might familiarize yourself with switch statement in those languages. However, similar to switch statement, we have something called when statement in Kotlin. The way it works is that we define a variable that contains a value, then we say, hey, val result is equals to when day one. So now again, this behaves as an expression. So this will return a value for us, meaning that when it executes, any one of these cases, when it's true, will return a value and will be saved inside the result variable. So here when behaves like a switch statement, and you can use these cases. So in Java or C Sharp or C++, you might use case 1, case 2, case 3. However, in Kotlin, you just provide the values. So whatever the variable value you want to evaluate, you provide those values here. And if the value matches with this thing, because we are passing it this in as an argument, whenever the value matches, its arrow function defines that, hey, execute this line of code, which basically means that assign it back to this result variable because we are using when in this case as an expression. Hence, after the when block ends, and when we print the value of result, it will print Thursday for us because that's the day number 4. Make sense? Yes. So basically what when does is that it does an equal to comparison, where whatever value we provided there, it will map with this cases here. Whatever is the value, it's going to match and evaluate whatever matches with this. If nothing matches, the else statement gets executed and an invalid day parameter is assigned to this result variable value. So when expression is similar to switch statement, as we said, this when expression is same as in Java or C Sharp. The when variable day is evaluated once. The value of day variable is compared with the values of each branch. So this is known as branches. In this case, they are referring to as a branch. So this value day is evaluated with against each branch. Whatever gets true gets assigned to the variable result. Okay, so each branch starts with a value followed by an arrow function. If there is a match, the associated block of code is executed. Else is specified in some code. Again, else is not mandatory, but in this case it is because we need one value to be assigned. Okay, so in this example above, the value day is 4 is matched and Thursday value will be printed. Make sense? So this is how basically when works. Let's talk more about while loop. Well, loops in programming generally allow us to use and cycle through certain lines of code, which means basically that if you provide something inside a loop, it will keep on repeating and executing itself until a given condition is satisfied. That's what loops does. So we have a while loop, we have a for loop, we have other forms of loops, we usually do while as well. In this case, let's talk more about while loop. So while or loops can execute a block of code as long as specified condition is reached. In fact, we defined that the loops will cycle through a continuous block of code. So it will cycle through, keep on repeating itself until a specified condition is matched. Loops are very handy because they save time, reduce errors, and they make code more readable. So in Kotlin, we use while loop with the following syntax. We provide while loop condition. Now, notice the bracket start, bracket close, and then we provide a condition. Now, what do we mean by condition? Same condition that we use in if-else statements. So we used if-else statements and we provided a condition there. So here, the condition goes exactly same thing. So whatever expressions using less than, greater than, equal to, not equal to you write here, they return true or false. If it is true, the block of code will execute. The moment the condition becomes false, the block exits. The block will continue to execute until the condition is satisfied. So if the condition is true, the block will execute, cycle back to the condition, again check the condition. If the condition is true, again will execute the block, cycle back to the condition. So this cycle just keeps on repeating and repeating and repeating until the condition becomes false. So we need to be very careful about the condition because we want to ensure that at any given moment the condition does need to be false. So in this example below, the code in the loop will run over and over again as long as the counter variable is less than 5. So we declare a variable I is equals to 0. We define it inside a condition that if I is less than 5. So notice the condition again same as if else, but the key difference between if else and while loops are that if else only executes once. So if the condition true, it executes once, while the while loop will keep on repeating itself until the condition becomes false. So that's why we need to have a variable that actually changes its value over time to ensure that the condition becomes false. So we say, hey, I is less than equals to 5. The condition is true because currently starts with 0. The block of code gets executed. Then within the block, we write, for example, print statement, print the value of I, and then we do the increment. The increment operator here is plus plus, which basically means take the current value of I, add 1 to it. So plus plus will always add 1 to it. So add 1 to the current value of I and then again override the new value. So now I becomes 2, or sorry 1, because we're starting from 0. So I becomes 1 for the first time. So then again it goes back automatically to this condition because that's what while loop does. It cycles back to its own condition. Now I value is 1, less than 5, again true, again execute, print the statement, do the increment, make it 2, again cycle back to the condition, check the condition. Now 2 is less than 5, still true, again cycle back, and then similarly just keep on progressing.
Okay, so the most important thing is, again, we need to ensure that we do increase the variable's value. Okay, so here it mentions that do not forget to increase the variable used in the condition. So this I plus plus is key here. If you don't use this would basically mean that the value of I will remain 0 forever and the condition less than 5 will remain true forever. That would render an infinite loop. So if you try this currently code out, you see that it starts from 0 because again I is 0 and then condition is less than 5. So that means that it will go from 0, 1, 2, 3, 4, 5. But if you don't use this and you will leave it out, this will go into an infinite loop because every single time it checks a condition, it will keep on executing. So increment here is quite important here. Similar to while, we have a do while loop. The do while loop is a variant of the while loop. This loop executes the code block once before checking the if condition. So in this case, this loop is same, it iterates itself, but the only difference primarily is that the block actually gets executed first and then the condition is evaluated. In a while loop, it evaluates the condition first. If it is true, then it executes. So for example, in this case, if my value already is 10, if I run the code, now because I is 10, I is less than 5, the condition becomes false, nothing gets executed and the loop ends. Okay, because the condition right away became false. So we will not see any output generated here. See, blank. However, if you use do while loop, what happens is that no matter what, it will execute at least one time because the block actually is written first and then we have the condition ending with a semicolon. Okay, so semicolon again here is an important. If you don't do that, it's going to generate some error. So this thing will basically do the same thing, but executing the block of code once. So if you execute the code, you will see that you get the similar output. However, if you use the variable 10 here, so now variable I is 10, it's going to go do print the value of I, do the plus plus, makes it 11 now. The condition will check afterwards. So no matter what, this will get executed at least one time. See, so we get a 10 output no matter what. Okay, so even if the condition is false, but because the code is written first, the block is written first, in fact the condition is evaluated later on, so it generates at least one time output, then the condition become false, loop exits. So in certain situations you might come across where you need to do such kind of a loop where you want to execute at least one time and then check the condition. So that's where the do while loop comes into play. Again, keeping in mind, we have to make sure that we do the increment if we are just using a normal loop, so that it increments and then at the point the condition becomes false and the loop terminates. Okay, so that's how we use a do while loop here. Then we have something called break and continue statements. Now the break statement is used to jump out of the loop abruptly. Okay, in a certain situations we want to check a certain condition and then stop the loop's execution flow. So for example, we have variable I, we say I is less than 10, print the value of I, do the increment, all standard loop up till this point, but now we use an if condition here. So we say if the value of I becomes 4, what you do is you break the loop.
Okay, so it's what it does is it just breaks out of the loop. So in this certain situation, if the value becomes 4, then it's going to break out the loop. The output now is that it's just going to stop till 3 and then breaks out. Why? Because again, starting from 0, it's go 0, then I plus 1, condition check, condition becomes false, this line is ignored, it goes back up again. Now I value is 2 because we did the increment, and then so 2, 3, up till the condition it becomes 4. So when I value is 4, we have written a break statement. So what break's going to do is it's going to break the execution flow of a while loop. Okay, break usually we write inside the condition statements to check a certain condition. If the condition is true, only in that situation you break, meaning stop the loop and just come out. So this is again a numerous times this happens, and there's various different situations where we want to loop through an element, but if we find something, for example, searching algorithms do that quite often. So if you have long list and you want to search and iterate through each element and search for a certain element, as soon as you find the first occurrence of any element, that means you have found the element 4, just break it out from the loop. Okay, then we have something called continue. Continue statement breaks one iteration in the loop if a specified condition occurs and continues with the next iteration. So what it does is actually it just skips a beat. So it continues the cycle, but if it reaches the condition, it breaks that cycle and then recontinues from the next one. So in that case, we will skip a particular value in this condition. So if you execute the code, what happens again, we usually use it inside the if statement. So we again start with var I is equals to 0, while I is less than equals to 10. If I is equals to 4, do the increment. So that again, we want to ensure that there's always an increment, and then do the continue. What this is going to do is start from 0, 1, 2, 3. Notice there's no 4 here. Why there's no 4 here? Because it skipped a beat. It skipped an execution flow. Hence, this line was not printed. Because we are using continue, it's going to skip the beat. We have to ensure that we do I++ also inside the if statement. So at least the increment is done. Otherwise, it's just going to keep on skipping the beat. So if you don't use this I++ in this case, and if you continue, what's going to happen is that now it's when it goes to the 3, and then it just keeps on continuing and continuing and continuing and continuing. Okay, so this loop will continue, hence it generates errors every single time, because it says, hey, that the function must be declared, there has to be a single value, and then it just keeps on continuing. So this becomes a syntax error. Okay, then let's talk more about arrays in this thing. Now, Kotlin arrays, well, arrays are basically known as collection of similar or different data types. Okay, so we define arrays as having a collection of data type. Instead of arrays, previously we have used variables and data types in normal sense. So what variables does, at any given moment, a variable holds a single value, whereas arrays allows us to hold multiple values in a single variable. So in a single variable, you can use multiple variables or multiple values. Okay, that's what how we define arrays. So arrays are used to store multiple values in a single variable instead of creating a separate variable for each value. To create an array, we use a function called array of with O capital, camel case function, and place the values inside a comma separated list. Again, this is in Kotlin. If you're coming from C#, Java, or C++, you usually notice that we use a square brackets to define the value. If you're coming from Python, we have lists, sets, tuples. They are again with different ways of declaring. But in Kotlin, we have a specific function. Okay, so in this case, we have a specific function says arrays of. So using a function, we actually declare a variable arrays. So we're now telling it, hey, declare variable value called cars. Make sure it's an array of with a capital O. Please do keep that in mind. And then bracket start, bracket close, and then we provided values. So since we are using string, inverted quotations, if you use integer, no need of inverted quotations. So these values are all what we call comma separated values. So we separate these values with comma. Obviously, the last value does not need a comma because there's no more value here. So what this means that this single variable arrays cars now is an array containing multiple values. Okay, so this single variable car is an array containing multiple values of type string. Okay, how do we access and use this thing? So to access and use it, we again use the square brackets. So we say, hey, I have a value cars, arrays of this values. Now, if you want to print it, we use println, we use the variable name, and then proceed it with square brackets, and then this 0 is known as index number. What's an index number? Index number is basically a hidden number that is assigned to each value inside an array, starting from 0, 1, 2, 3. So every time you declare an array, you actually provide an data to it. But each data is internally mapped to an index number starting from 0. So the Volvo has a 0 number, BMW has 1, Ford has 2, Mazda has 3, and so on and so forth. No matter what the value, you can change the values. The index number always is same. The first element of an array always goes on a 0 index. The second element, doesn't matter whichever value is, will go on a 1 index, and then so on and so forth. So to access it, we use these square brackets with an integer number providing the array index value. So if you use this will print the first element in your array, which is Volvo. So if you change this to, for example, 2, now it means that I want to print the second element of my array, which starting from 0, 1, 2. So Ford is actually at the second index. So whatever item is here is actually gets printed here. See, we get the Ford output. Okay, make sense? Perfect. So just like strings, arrays index also start with a 0, the first element, and then 1 index, and so on and so forth, as we talked about. You can change the array elements as well. So to change the value of a specified element, refer to its index number. So what we do is we say, hey, car, 0 index, change whatever element was on a 0 index to Opel. So again, as I said, the values actually doesn't matter. It has implicitly a 0 index. So every item starts from 0. 1, 2, 3, the index numbers remain constant, the value can easily change. So we can change the item value on a 0 index by providing it this thing. To print it, we use the same syntax inside the print method, or you can use the syntax to change the value as well. So in this case, for example, we can say, hey, I have a value cars. It's an array of these car names containing 4 values. Then I want to change the value at 0 index later on in my code from Volvo to Opel. So we just simply use square brackets 0, and then when we print the same thing, it's going to print Opel instead of Volvo. That's how it's supposed to work. Every array element has a default parameter or a function called size or a length that returns the number of elements inside that array. So if you use array Volvo and then you use cars dot size, again notice the dot operator here. Dot is a connection operator that connects an element within its data. Okay, or in other words, in this case, an object with its functions. So cars behaves as an object, and then it has this built-in function called size. So what it's going to do is, hey, go inside this cars variable dot size, find me the size of this thing. So it's going to return 4, which basically means that it has 4 elements. Okay, remember, it returns 4 in terms of counting the numbers, not based on the index value, because the index is 0, 1, 2, 3. So index is actually 3. So the last item has a 3 index, but the total number of elements inside this array are 4. So the size parameter is going to return the total number of elements, not the index number. Makes sense? So there's the size and the index number always will differ by 1. Okay, so because the size counts the values inside it, and the index number starting from 0 has an index number based on whatever elements there are. So if there are 4 elements, the index number maximum will be 3, but the size is actually 4. That's how we use it. If you're coming from Java, C#, I think they use the method called length. Okay, so that's why we say array length slash size, just to make things more clear. In Java, we use array.length. I think C# also uses array.length. So does C++ as well. Check if the element exists or not. So usually this is more common practice of using it. We use an in keyword to determine whether a variable or whether a value exists in an array variable or not, just like searching. And this in char parameter allows us to do the searching very easily inside an array element. And that's where the actually true potential of array elements comes into play. We can store data, and then we can very easily loop through and process the data, search from something within the same array elements, rather than having different variables and then try to access values from single individual variables. So here we are using if Volvo in cars. What we're doing is we are using a string to see if this string or this car name exists inside this array element. If that is the true, if it does exist, it's going to return true for us. This in keyword is by default has this true parameter also built into it. True means Boolean parameter printed into it. If it found this value, it's going to return true. If it doesn't find, it's going to return false. So second, it will automatically iterate through each element as well. So in is actually a very powerful keyword. What it is doing is multiple functions. First, it is going to iterate through or traverse each element of an array, then compare it with the value provided here. If the value matches, it's going to return true. If value is not found with amongst any of this, it's going to return false for us. So this all three major things, operations, are actually handled internally by the in keyword. And then obviously, because it's going to return either true or false to us based on value found or not found, we use it inside the if block, and then so we can make a decision that if the value is found, we can do certain operations on it, or in this case just print a statement. If we don't find a value, that means that we go inside the else statement and do an alternative statements. Okay, so if you execute the code, we see it exists. But if you change the value to something called wall and run the statement again, because now we have changed the string, this will not be found in any of these elements. It should return false for us, and then because if is false, this line is ignored and the else statement gets executed by default, and it's going to print it does not exist. So in is used to search an element inside an array and automatically tell us whether it exists or not. So the searching can be done using in. Loop through an array. So you can manually loop through or traverse elements as well using the for in loop syntax. So often when you work with arrays, you need to loop through all of its elements, traverse them, print them, process them, search them, do certain calculation on them, whatever you want to do. So you can loop through the array elements with the for loop, which you will learn even more about in the next chapters using the for loop. The following example outputs all the elements inside a car array. So we say cars, create an array of using the car names. Then we use the for loop similar to the while loop, but this is again called the for in loop. Again, for loop does the same thing. It will keep on cycling until a condition is satisfied. But this time the condition is using the in. That's why it's commonly known as for in loop. So here what we're doing is we are telling it, hey, listen, go inside this cars array, search for every single element. But because we haven't provided any string to compare it with, what it's going to do is automatically traverse the first element and return the first element. And then we're going to assign it to the X. And then we're going to print it inside the for loop. Then it's going to go because it's a loop, it's going to reiterate, go and read the next element, assign it to the value X, overwriting its previous value, and then we print the X value. Then again loop, see if there is a next element, again read the next element, assign it back to the X, and then print the X element. So again here in, because we have used with the for doing multiple things at the same time. First, it's going to traverse through all elements. Second, it's going to read the first element and then assign it to the variable X automatically. Then it's going to, again when it executes, it's going to check is there any next element in the array or not. That's a key thing. Otherwise, it doesn't know where to stop. So it automatically knows that and checks whether if I have a next element or not. If I have a next element, read that element and assign it to the variable value of X, overriding the previous value. Then X is printed, again loop is executed. Now because it will keep in mind that I have already read the first two elements, from that point it's going to read the third element. So it's not going to print Volvo again and again, it's automatically traversing through each element, reading each element, traversing it here, assigning it to X. Then when it reaches the last element, again it's going to print it, but now it knows that I have reached the last element. So the fifth time in fact, when the loop executes, it knows that there's no more element here. The loop, the array, all items have been traversed, and it's automatically going to return false. And because the condition becomes false, the loop will exit. So the in keyword is doing multiple tasks at the same time in this case. Again, traversing the elements. Second, it's going to assign it to the value X. Third, it's going to check the next element. If the next element exists, again the loop executes. And then when the element list is exhausted, it's going to return false. So it's automatically doing many things, just one single keyword. So in is quite powerful in both the situations. Okay, so if you use it with the if, it's going to do comparison, compare the left hand side value if it exists in the right side array or not, traverse through each element. If you use it with the loop, it's automatically going to loop, read the element, assign it to the value of X, and then check the next element, assign it, next element, assign it, a value ends, khalas. Stop there. Make sense? Perfect. So do use for in loop to traverse through list of elements, and then once we have the elements, we can do various different calculations, do comparisons, more advanced form of searching, and or whatever not you want to do in that. Okay, that's it. So now next we're going to talk about for loop. Now, what do we mean by Kotlin for loops? Well, Kotlin for loops, just like in previous session we talked about while loops, for loops also does the same task. They loop through elements until a condition is satisfied. So often when you work with arrays specifically, you need to loop through all of these elements. To loop through elements, you use for loop together with the in operator. Now, in for loop, we always use in operator, indicating that we want to use this, especially with arrays. Now, for example, we have an array of variable values. We save them in a val cars. Now, what we want to do is we want to traverse all these elements. To do that, we use for in loop. Now, we've talked about in previous session as well. What in does is a very powerful keyword with the simple syntax of in. In automatically traverses all the elements inside an array one by one and then assigns each element in this x variable. Then we can use this x however we want inside the for body. Then it traverses the next element, assigns it back to the x, overriding the previous value, and then we can now use it again. Similarly, third value, fourth value. So automatically in keywords will go inside this array, read each single element, assign it to the x, then goes, checks if there is a next element. If it is, assigns it back to the x, and then so on and so forth. So it uses this for in syntax to loop through these elements. You can loop through all kinds of arrays. In this example, we use an array of strings, but you can also use arrays of integers as well. So for example, if you have an array of integer values, same syntax. You use for in x in nums. Okay. So now what's happening here is again the same thing. We use for loop x in nums. So it's going to read each element inside this array, takes the first element, assigns it to the variable x, and then we use it to print the output. Then it traverses the next element, assigns it to x, overriding the previous value, and then we can use this x now here. Similarly, it will go through all these elements. Once it reaches to the end of the loop, or end of the array, sorry, it automatically returns false, that hey, there's no more element here, and the loop terminates. So using this simple syntax, we can traverse through array of like 100 or 2000 or million of data, but just simply use these two lines. That's what the for loop allows us to do. Okay, it allows us to traverse through. So using a simple syntax, we can loop through multiple elements. Traditional for loop. Unlike Java and other programming languages, there is no traditional for loop in Kotlin. Do keep this thing in mind. So if you're coming from C, C Sharp or Java, you will notice that the for loop syntax is quite different. In Java, we use variables to declare and initialize. We use a specific condition ourselves. Here we use for in loop syntax. So it's quite different from that. In Kotlin, for loop used to loop through arrays, ranges, and other things that contain countable numbers of values. So now it also uses something called ranges. Let's talk more about ranges now. Here we are. Now, what do we mean by range? Well, range is a specified range of characters. Okay, so you can specify a sequence of characters using a range parameter. So with for loop, you can also create ranges of values with these double dots. So double dots are key here. Using these two double dots, we can specify a range that I want to start from this value up till this point automatically, and you don't have to specify it manually. So for example, if you want to print the whole alphabet, you can do that by simply saying, hey, for characters, again, this becomes a variable. You can assign it any value. And then you can say in, start with the A character, double dot. Okay, so these double dot are Q, go up till X. So what this basically means that I want to start from A up till X, and this double dot will automatically ensure that you're using a range. So if you execute the code, you will find that it goes from A to X. Entire alphabet is printed without even specifying it here, because internally we have specified the range. Similarly, you can use number sequence as well that you can use to specify in terms of range. So for example, if you want a range between 5 and 15, you use 5 double dot 15. So double dot here specifies the range parameter that you can use. For programming like Python has the range function defined, where you can use the range function for the defining the whole range. And Kotlin, just double dots does the trick. So even though if you use 5 double dot 15, it means you want to start with 5 and you want to go up till 15 or any other number for that matter. So this is 15. Now keep in mind, 5 is also inclusive as well as 15. So if you specify 15, it means that I want to start from 5 up till 15. So this is also an inclusive number. Programming like Python has a range function, but the last number is usually exclusive. So it's always one number less than that. To keep this thing in mind. Here when we specify 15, it means it's an inclusive number. I am going up till that 15 number. So whatever number you specify here, the range will automatically go up till that point. You can start from 0 to number 1 to 15, or whatever range you want from between these numbers, you have that using the double dots. So checking if the value exists within a range or not. So you can also use the in operator to check if the value exists in a range, meaning that you can use in function to find a particular number. Okay, do the searching within an array list. So to do that searching, we again use the same in loop, and then we specify the syntax in terms of that, hey, if to in nums. Now we have discussed this in if else already to a certain extent. You can use this in function. So we are specifying now is that, hey, listen, I have an array, but I want to find this number. So instead of using a variable name, we specified a value. So once you do a specify value, what it is going to do is just automatically in is going to take this value and search it inside this array. If the value exists, it's going to print, hey, the value exists. If it does not find this value, it's going to return that it does not exist. So in again is a quite powerful keyword. Similarly, you can find any string as well. So if you specify string value and then use in function inside the if, it's going to say, hey, I want to do search this array, find this value. If it exists, return that value for me. And then you can use whatever operations you want. That way you have a very nice sequence of characters and you can do very easily searching within the range. Similarly, we have break or continue a range as well. What break does is that you can also use these two keywords and it does the same task as we talked earlier with the loop. It breaks the function. So for example, I can use for nums in range 5 to 15. And if you find the value, so if you use the if condition, again, that's what recommended every time you need to use break. Make sure you reach a particular condition and then you specify, hey, nums is equals to 10, means that I want to start from the nums, check if the value is 10. If the value 10 reaches, break the loop. So the loop just breaks it out. Okay, so if I execute the code, you see that it starts from 5, goes up till 9, and then at the 10 point, it breaks the loop and there's no more output here, even though we have a range up till 15. So we can specify that. Again, just to for useless point, but it's there. So you can use break inside a for loop as well, just like we use break and continue inside the while loops as well. So the skipping a value also means that you use continue, same as we did in while loops. You can very easily say, hey, I want to skip a particular value. So if you reach 10, please skip it. So we use continue and the loop just skips a beat and then it just prints the next value instead of printing the first value. So here you can see that we have 9, but the 10 value is missing. The 10 is missing because we skipped the value 10 here. So we have specified, hey, start from nums, take a range 5 to 15. But if you find the value 10, I don't want to print this value. So for whatever reason that is. So we have skipped the beat using a continue statement. So continue and break also works with the for in loops as well. Make sense? Wonderful. Now the last topic in our basic Kotlin course is functions. Let's very quickly discuss what do we mean by that. Well, we have been using the main function for all our examples previously. We talked about the fun keyword that defines that we are using our own custom function and we have put everything inside the main function. But you can create your own functions as well. Function typically is considered as a block of code that performs a specific task. Okay, so function is a block of code which only runs when it is called. That's another second thing. Basic logic is that you declare your custom function that performs a specific task. So anything you want to do, you put it in functions. It makes the code reusable and repeatable. So you can call the function again and again as long as you want to perform the same task. Okay, so instead of writing the code multiple times, you just put the code inside a function and then you can call the function multiple times. That's what it does. It allows us code to become reusable and more professional looking and more customizable. So it is a block of code which runs only when it is called. So that's the key thing, that you need to call it. You need to declare it and then call it. You can pass data known as parameters into the functions as well. So you can give some data to it so that it can operate on it. Functions are also used to perform actions. They are also known as methods. Okay, what do we mean by that? We'll discuss that in a moment. So here's a predefined function. So it turns out you already know what a function is. We have been using main function. Okay, so for example, println is also a function. It is used to output print text to the screen. So whenever we have used println, again we are calling a predefined function that's already built, and we are calling this function with an argument that, hey, this is a string that I want to print on an output. So main is also a function as well as println. So how do we create our own functions? Well, to create your own functions, we use the fun keyword, just like we did with the main method, and write the name of the function followed by a round parenthesis. Okay, so what we do is we say fun, my function, this can be any name, making sure the name does not contain any spaces. You just follow the standard convention, does not begin with a number. It can have underscore, it can have number as a second character, but usually first character number are not recommended. And then again, no spaces as well. So as a single word, we use it. So if you're using two words, we use the camel case from my, and then the second word begins with an F capital. Just and the convention, not the rule as well. So you can just write in a simple word as well. But as a writing convention, we use a camel case code. Then these round brackets indicate that this is a function. So this is the key point here. Bracket start, bracket close, and then some actions that they need to perform. Now you notice we have called our own println function inside the main function as well. So this is also known as function declaration. Means that we have declared a function, that this is a function, it's going to do this task, but it's not going to execute by itself. To execute it, we need to call a function. We need to call this thing. So now that we have created a function, you need to execute it by calling it. So to call a function in Kotlin, write the name of the function followed by the two parentheses. In the following example, the function, my function, will print some text and when it is called. So in this case, we are using function main, and inside this main function, we are doing function calling. So we are just calling our own function using the name function. Notice there's no fun word anymore needed, because the fun keyword is used to define a function, to declare a function. So once we have declared it, now to call it, we don't need to use this keyword. We just call our function name with the parenthesis. This is called function calling. So if you execute the code to see how it was working, here we go. So you notice two main things here again. First, the function is declared outside the main function. That's a key thing. Okay. So functions are usually declared outside the main function. Typically, we declare them before the main function is called. So that way the system already knows that this function is there. Then we say, hey, function main, and then we call our main function. So you can call this statement multiple times. The key thing is I've just got executed. You can also call it multiple times by meaning that you can execute this function multiple times. So if I rewrite the function, run the code again, as you would have already guessed, yes, it's going to print the same line twice. Okay, so this basically means that we have a declared function. Now I can call this function as many number of times as I want inside my main or in any other function as well. Every time I use this function, it's going to execute the statements here. That's what we mean by reusable code. Then now if it performs a specific task, you don't need to repeat this task code every single time. Just call the function name, it's going to execute and do the task for us. Okay, so a function can be a multiple, you can call the function multiple times, exactly the same thing that we talked about already. So if you can call it 2 times, 3 times, 4 times, it's just going to execute the same line as multiple times. The parameters. Now, this is again a key thing. An information can be passed to a function as a parameter. So parameters are specified after function name inside the parentheses. So you can add as many parentheses as you want, just separate them with the comma. Do note that you must specify the type of parameter in this case. So for example, when we declare our function, we have used function name string. Okay, so here we have explicitly told it that, hey, I want to declare a variable called fname, but colon string, meaning we are explicitly telling it that I want to declare this function of type having a parameter fname of type string. So the data type has to be specified. Then we can use the same variable inside our function body anywhere, anytime, multiple times, however we want. So I'm using fname because it's my variable name, fname here plus do. So whatever string I provide as an argument here will come back to this point here and will be printed. So now this is called function declaration. The key point again is the way you have declared a function, you must use the same signature. By signature, we means that since it has my small f capital, I use my small f capital. So the naming convention has to be followed. Second, because it uses this argument, it requires a parameter. So we need to provide it an argument. So in this case, we need to provide it as a string. So we need to follow the exact same signature. This is a function taking one argument. So we need to provide that argument here. If you don't provide an argument here, it's going to give us error that, hey, the declaration requires an argument and you have not provided an argument. You need to do that. And if you provide multiple arguments, again, it's going to complain that I only need one argument. Why you need to do more arguments? So in that case, this is an error. Now, the beauty here is that because we have my function, you can call this my function with a multiple different types of parameter, and it's going to print the whole code for us. So if I execute the code, notice that every single time it's just changing the name. However, the function is same. So that's where the reusable code comes into play. So So you provide a different argument. Based on the argument, it's going to do its task. So whatever argument you provide, it's going to do the task. So for example, if you're creating addition, so every time you change the values, it's always going to do addition based on the arguments you provided to it. So now we have John. Again, if I don't provide an argument, this is going to complain that, hey, I need an argument. Please do provide that. So make sure we follow the signature by meaning naming convention and the parameters that are specified here. Okay. So when parameter is passed to a function, it is called an argument. Keep this thing in mind. Usually the words in a sense are used interchangeably like synonyms, but basically we say, hey, this declaration here is parameter, and then when we provide the value here, this becomes an argument. So from the example above, f name was a parameter and the John, Jane and George are arguments. Multiple parameters. Now you can obviously provide multiple parameters, making sure they are comma separated. So comma separated means that I need two arguments in this case. First being f name, string, comma, second being age, colon, type integer. So the first argument has to be of type string, the second has to be of type integer. And then we can use this age variable as well as f name inside our function body. When we call this function, again we follow the same signature, making sure the function name is exactly the same, bracket start, bracket close, and then we provided now this time two arguments. First has to be of type string because we have specified a string here, and then second has to be of type integer because we have provided this to be of type integer. Kotlin will automatically assign the string to this f name. The second argument will go automatically and be assigned to this age. Okay, so that's why these arguments are also comma separated, indicating that this is the first argument, comma, second argument. First argument, comma, second argument. So the first argument is assigned to this f name. The second argument is assigned to the integer. Now notice again, we have called this function multiple times, just changing the values. Every single time you print it, it's going to print a different output for us. So for every function, we will have a unique output. That's what the power of function is. So when working with multiple parameters, the function call must have the same number of arguments as there are in the parameters. The argument must be passed also in the same order. Okay, so do keep this thing in mind. The order also matters. By order means that if you change the order, so let's try this example out. So for example, if I use 35 first, comma, and then I use the John here. So what's going to happen now? Error. Why error? Because the first argument has to be of type string and we provided an integer number, whereas the second argument has to be of type integer and we provided a string. So this created a complications. So the type and the sequence also matters a lot. That's why we use the word signature. Follow this declaration signature. Name, argument, argument type, argument number, everything has to be same. So if you skip an argument, for example, I just provide 35. Again an error. Why? Because there is no value passed for the second argument. So the first value will always be assigned to the first parameter. The second argument has to be in the second argument. But if you don't provide it, it's going to complain. So that's what we need to be careful about, the signature of a method. So a function that we declared has to follow a specific signature. Okay. So when working with multiple parameters, the function call must have the same number of arguments. It's a key thing. So you need to follow the signature of the syntax very clearly. Now let's talk more about returning values. A function can return a value as well. By return value, we means that when we call a function, after executing, it's going to return a reply to us. Okay. So return value means that this function not only just prints the thing, but it actually gives an answer back to us. So by that we mean that, for example, if I ask somebody to bring me a glass of water, so that means that I have a function, that task is go bring the glass of water. So what the function is going to do is it's going to go get the water in the glass and then it brings back to me. So I have to be there to receive the answer as well. So the answer is, or the task is to bring the water back to me as well. Make sense, right? So when it brings it back, I also need to be there to receive the answer. So this is what happens when we do return type. First, I need an answer back. So I have to say, hey, bring the water back to me. And then second point is that I also have to be there to receive the water. So how do we do that in coding? Well, we use a word called return, which basically means that I want an answer. Just don't print the output on the console. We can do that. But after that, we say, hey, once you complete your execution, I want a type return. Okay, so this return basically means that I need an output. Now the syntax or the signature little bit changes. What's happening now is that we declare a function, we declare a type. I said, hey, x call an integer, so one parameter we have specified. So in order to create it requires one parameter. But now also notice that we have a colon and integer as well. What this specifies is that once this function executes, this will return a type integer value. So this colon after the parentheses indicate that this function will return a value. So when I use a return x plus 5, this return will actually go to this point, indicating that the answer has to be of type integer. So this is the declaration syntax. So in this syntax, we declared that, hey, I have a function, takes a single argument and returns an integer number. The function, and then because I've used this here, I must also use a return statement within my code, making sure that the value is actually returned as a part of declaration. Then when we call it, means that now the function will be asking it to go and fetch us the glass of water. So we call the function, we provided an argument, then we say, because we are expecting a reply, so now I am expecting a reply here. Variable result. So whatever your function task is, perform that task, then it returns a value, and then I have to be here at the receiving end to receive the answer as well. So in a simple sense, we have asked the function, do this task, and then the return a reply to me. Because it is going to return the reply, so I have to be here to receive the reply as well. So variable result, this part is actually receiving the answer, and then we can use this reply to get the output on the console. So if you execute the code, you will notice that what's happening now again is that we get 8. How? Because we have said, hey, function 3. So we passed it one single argument, we added with 5, and then we are telling it we need an integer as a return type. That's why we have a return here and it performs. So for example, instead of my function, I can say, for example, my add. So we declare in my add function, I can say x, y, colon, another integer number. So now it takes two numbers, adds them together and returns it to me. So x plus y. So you can have your own function as well. And then we have specified colon integer after the brackets. So when I call this function, I'm going to say, hey, my add, and because I know in my signature it requires two parameters, so I'm going to give it two arguments. So 3 plus 5 here. So now it takes two values, sends it to the add function, it adds these two things together and returns an integer number to us. So this variable will now have an integer number. So if I execute the code, it prints the 8 here. Okay, so the same thing goes, but this time it takes two arguments, sends it to these parameters here, it adds them together, returns an integer number with this return keyword, and then that return answer is actually saved in a variable. You could also do this next thing is that, for example, you can write println statement, and then you can write this my add function directly inside the print statement as well. So you can specify values to this thing. Now if I execute the code, see what happens. We get 12. Why? Because obviously first one 5, 8 is from the previous answer. This time we have called the my add function directly inside another function, and this is perfectly legitimate value. Now you could say that, hey, it needs a result variable, right? But no, what's happening now is that we have called this my add function. So it's going to call this, it needs two arguments, so the syntax is fine. It takes two arguments, adds them together, returns a value in form of integer, and that integer is actually directly passed to the println. So the answer is still being received by println. So you can use my add function directly inside println, and because println also needs some form of data to get printed, that data is actually being handed over by my add function. So my add function will directly send the data to println as a receiver, and then println actually prints the output here. So in this case, we have received in a variable. So result behaves as a variable and receives the answer. Here, println behaves as a receiver directly and prints the value. So you can embed this my add function directly in a println as well. Similarly, you can add it inside another function as well. So you can create a nested layout as well. So for example, I can say, hey, let's go for println bracket start bracket close. I do my add. I call this function, and I can have, for example, 2 comma 2. But this time, instead of using the 2 value, I can use my add and then another value, for example, 34 comma 7. Okay, so now what we have done is we have used the nested calling function. This is again a perfectly legitimate thing. What's happening now is that I have a print method. Inside the print method, I have a my add method. Okay, so inside my add method, it takes two arguments. It needs two arguments. So the first argument is there 2, but the second argument itself becomes another function call. So first of all, it's going to execute this innermost function, does the addition, returns the answer, and will be assigned to this my add. So then the second my add will execute, and this the second argument will actually be the reply from this argument. And then we will have my add perform its calculation. Whatever is the answer will be returned to the println. So if you execute the code, you see we have a 43, perfect answer. Why? Because again, so 37 plus 4, whatever is the answer of this will be returned to and added by 2. Whatever is the answer for that will be returned to println, which ended up as being 43. So you can use nested functions as well to do more complex form of calculations or more recursive calls to functions to do more advanced level of tasks. Make sense? So that's why, again, see, this function reusability comes into play. Okay, so now using two parameters, we again does the same thing. My function returns x plus y, results whatever the answer is saves in here, same things. So a shorter syntax for return as well. So you can simplify this code if this with this shorthand operation as well. So there is also shorter syntax for returning values. You can use the equal operator instead of return keyword. How does this work is, so instead of using the return keyword, you can directly specify in your function syntax within a single line using the equal operator. And notice there is no block statements now. So I have a function, my function takes an argument 1, takes a second argument integer. So two arguments are there. So instead of specifying the data type and the block, if this is the only thing that is doing, if there are multiple lines of code, then this won't work. Okay, so for example, it takes arguments, does some calculations or analysis or validation, then you need the block of code. The first syntax has to be there, then it may return the value. But in this case, if the only purpose is to do the addition, you can directly write it as a shorthand by using this. So is equals to x plus y, that's it. So no return type is specified here. So this return type is also not specified here. The block is not specified here. The return statements, this is nothing is specified here. Directly equal to x plus y. So in other words, if it only does a single operation as a return type, single statement is there, then you can use equal to operator x plus y, and then it will automatically know that it's staff type integer. We don't even need to specify the return type. So when you use my function 3 plus 5 does the same task. Make sense? A little bit, right? Perfect. Okay, so I hope you understood this. Now, if you have been following me, please leave a comment. Let me know what more you want to know about Kotlin, how you're using Kotlin. Hopefully in future, we will be using Kotlin inside Android Studio to create more apps using Kotlin within Android Studio as well. So let me know if you're interested in that course as well, so we can start Android app development as well. So up till now, thank you for watching. I will be again posting the next sessions soon, but I want to know if you guys are interested or not. If nobody's watching again up till this point, not many views, so it just makes a little bit disheartened. So you don't want to make more videos on this topic. But yes, if you are interested in learning Kotlin classes and other examples and Android with Kotlin, do leave me a comment and let me know if you are interested or not. Okay, and then I will be hopefully trying to make the videos based on your interest. This is Dr. Zishan Bhatti from W3 Schools, Learn with W3 Schools website. Thank you very much for watching. See you in next class.